Okay, so far we've always given you problems that look like one of these two. The one's long division, the one's synthetic. And we're asking you to factor. That's really what we're doing. You're factoring the big giant thing that's the dividend that's under the den. Right in there. That thing is being factored. But we've always told you this. Or we've told you the root. It's either the factor, see, that would be like this, or it's the root, which is the thing that would make that factor equal 0. So we've always given you those. So how do you know what could possibly work? Well, there's a way. And what I'm going to teach you today is called the rational root theorem. And the rational root theorem tells you rational, well, okay, it's going to be a rational number. And the root is obviously the thing we're looking for. This is the root. It's also known as the 0, etc. This rational root theorem says that if you take f con over f co, this is something that's worth writing down. F con over f co, just write it down. I'll explain it in a second. That will tell you what could possibly be a root. So again, if I didn't give you this x plus 1, if I said, what do you think might work? Well, you look at your equation in question, and you take the f of the con and the f of the co, and you divide them. Take a guess what f means. In the context of factoring, the factors of the, what do you think the con is? Nope. Factors of the constant. This is the constant. And the factors of the co, the lead coefficient. Very good. All right. And the factors of the lead coefficient, the very front. So basically, it's the front and the back that'll tell you what could possibly work. All right. So what is in the front? There's a 1 there, isn't there? Really? Okay. So then, the factors of the constant. What are the factors of 5? 1 and 5. And it's not really plus. It's just the factors 1, comma 5. And would you agree that -1 also goes into 5? And -5 also goes into 5. So I need the plus and the minus of both. -1 and 1, and 5 and -5. Those are all the factors of 5. We're even getting a little creative by throwing in the negative ones there. All right. The factors of the coefficient, the f co, well, that's pretty easy because it's just 1, right? So what are the factors of 1? Yeah, and we should use plus and minus of the 1. Okay? Now, here's the pain in the butt part. That's actually a division problem. You have to take every 1 divided by every 1. So all you really got to remember with the plus and minus thing, just to keep yourself from going insane and having to check all those different things, is your answer just needs to be plus and minus whatever. Okay? So what if I take 1 and I divide it by 1? What do I get? 1. So 1 is a logical choice. And don't forget, make it plus and minus. So plus and minus 1. And another thing that could be it is what? Plus and minus 5, because you take the 5 divided by the 1. And you get plus and minus 5. So all the things that you could put out here, if this was going to be a great big long division problem, all the things you could put out here would be x plus 1, x minus 1, x plus 5, or x minus 5. Those are the only things that could possibly work. You get that? Those are the factors of the constant divided by the factors of the coefficients, and now I'll tell you what the roots could be. This is called the rational root theorem. It helps tell you the possible roots. Okay, now how do you check it? How do you check and see which one actually works? That's the part that can take forever if you did it with long division. So that's why we're happy that we can do synthetic. All right, so to take synthetic on this thing, we would say either 1 goes in the box and we go 1, 3, 0 to hold the place, 2, 5. Or we could try -1 here, or we could try 5, or we could try -5. So today you're going to get really good at synthetic because you're going to do it so many times. It's going to be just like zip, 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 check, didn't work. Check the next number, bzz, 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 didn't work. Yes, sir?
So we essentially have to guess and check.
That is correct. Is there a better way? Yes. But I don't get to teach you that till tomorrow. This is the rational root. There is no better way without a calculator. But with a calculator, there's a better way. Yes, sir?
When we put that number in the box,
Yep.
if there is no plus or minus, we just -5. When we put -5 in the box.
Okay, good question. If they give you x minus 5, you should say 5. If they give you x plus 5, you should say -5. But when you're testing, you have to test all of them. So, you know, it's not going to work to just test 5 and then you'll automatically know if -5 would have worked. It really isn't that simple. You have to test both of them. Yes, sir?
Wait, so you pick one, like let's say we do 1 right away.
Yep. Then you're done. You do not have to figure out all of them. It's the best idea is to work with somebody today and divide them up. And you're like, you check 1 and I'll check 1 and -1 and you check 5 and -5. By the way, always pick 1 and -1 because it's way easier. Yes, sir?
Is there a way that you could make a logical decision as to which would be more likely?
I get what you're saying, and a lot of kids have tried to come to that conclusion at the end of, you know, which of the two is more likely to be it. And I can't tell you that, other than sometimes you actually end up getting fraction ones. Like you come out with, let's say you do the factors of the constant, factors of the coefficients, and it's like this. 1 and -1, and 5 and -5, all over 2 and -2, and 1 and -1. And you have to do all those different combinations. Well, it'd be 1 over 2 is 1/2. 1 over 1 is 1. 5 over 2 is 5/2. And 5 over 1 is 5. And then it's plus and minus of all of those. Yeah, it gets ugly. So then I can tell you this. It's usually not the fractions, not because of math, but because we usually don't want the answers to come out with fractions in them. So usually the teachers aren't going to pick the fraction ones. Does that mean always? No. But if you wanted generalizations on, I'd probably pick these last, and I'd try to start with the easier ones, like 1 and -1, 5, -5. Okay. So the good part about today is there's not that many problems, and you already know how to do most of them. It's pretty much just doing synthetic. So it's just what do you test? And this FCon over FCO thing tells you that. So let's do one more practice on the FCon over the FCO thing. So I'm going to give you a problem. You tell me what the possible roots are. Make a list for me of all the things that could possibly work on this. 3x to the third plus 2x squared. Actually, I'm going to make this one actually work so that I know what the answer is. 6x squared plus 2x plus 4. Now figure out for me what the FCon over the FCO. And then actually give a final answer. These are the 5 things, plus and minus all these things, that I'd have to check. Okay, factors of the constant. That's the 4. What are the factors of 4? 1, 4, 2. And then the other 2 is exactly the same, right? And don't forget plus and minus of all of those. All over were the factors of the coefficient. 1 and 3. Plus and minus, plus and minus. Then you actually divide them all. Give you a hint. Dividing by 1 is really easy. Just write down the top numbers again. So the answer to this is 1 and 4 and 2. But then you have to divide by 3. 1/3, 4/3, and 2/3. Then, don't forget, it's plus and minus of all of those. And I do have a shortcut way that's okay with me. plus and minus of all those. And I'll get the idea that they're all positive and negative. Then, how many possible things are there? 1, 2, 3, 4, 5, 6 times 2 is 12. There's 12 possible things you have to check. Now, do you have to check all 12? No. But you keep checking until you find it. Did you already find it? Okay, good.
It's 2 on the test.
Yes, this gets ugly on the test.
You have to finally go through all of them until you find the rest.
Unless you figure out a better way tomorrow.
Will we be able to use a calculator on the test? This test?
You'll find out there will be some you can use a calculator on, but not all. So you do need to know this, because there are some that you can't, the calculator won't work on. But anyway, bottom line, you need to know this that I'm teaching you today. Now let's actually divide this up like I would recommend you do when you were working with people. Okay, so I'm going to do like this. I want you all to do, what's it called, synthetic for the number I give you. And there's enough people here that I can divide these up really easily. All right, I want you guys to check 1 and negative 1. I want you guys to check 2 and, no, 2 and negative 2. I want you guys to check 4 and negative 4. You guys, I'm not going to make you do the negative one just because it's harder to check a fraction. But you do 1/3, and you guys do 4/3. That's not that hard. And you do 2/3. You guys do 2/3. Okay, try it. Do synthetic. I want to figure out which one actually worked. As soon as somebody's got it, say I got it. You're doing synthetic right now. You guys aren't wussing out on the end there, are you? Come on. You guys didn't get the hardest one. It was the hardest one was 4/3. Oh, somebody said they found it. You confident? Double check yourself before we make everybody stop. Okay, fine. What do you think worked? All right, so are you saying negative 2 worked if you're doing synthetic? Are you saying positive 2 works if you did synthetic? Okay, so I'm going to go negative 2. You're saying negative 2 worked. Now, I know what you did, and that was smart, but, okay, anyway, here. 3, 6, 2, 4. Draw the line. Drop it like it's hot. Negative 6. Cancel 0. Multiplied by 0. Add these as 2. Negative 4. And it makes a 0 at the end. You are correct. It worked. Now, there are times when you can use your factoring skills, just general factoring skills. Did anybody notice that this one could be factored by grouping? And if you factor it by grouping, that can tell you what the factor was. All right, so we found it. Is it possible that somebody else could have found a different answer that would have worked? Yes. It is possible that you can have 2 things work out of your list of like 12 things to check. Maybe 2 of them work, but all you have to do is find one of them. And once you found it, then you need to actually finish the deal and get the final answer. So let me show you what I mean by that. The final answer for this one that you just gave me was, bring this down, x plus 2, and then this part goes in parentheses. This is the x's and this is the x squareds, and I put pluses, and there's the answer. X plus 2 and 3x, don't really need to say this part, plus 2. Okay, that's factored. All right, so that is factoring using synthetic and the rational root theorem. Okay, so for your homework for today, it's basically got a bunch of problems that at the beginning it just tries to show you how to do rational root, which I just showed you. And then you're just going to need to make a list like we were doing before. So the first few problems, don't actually factor them. You just have to answer what are the possible factors. And then the next few problems in part B and C, the worksheet's divided up into part A, B, C, and D. We are never going to do part D because they are that awful. We are going to do parts A, B, and C as your homework for today. Okay? So find your worksheet and just do parts A, B, and C of the worksheet. And I would strongly recommend that you get into groups. Remember that tomorrow, I was going to do it today, but it turns into tomorrow. I'm going to do that group session where I'm going to have people be recorded on video. These guys are going to be walking around looking at your group and seeing how you're talking and stuff with each other. If you want to be in the same groups as that, get in a group of 3 that you like so that I don't have to like pick a group for you. Okay, it's got to be 3 or 4. Groups of 3 or 4. Yes, sir. Okay, get up, sit by somebody you want to work with. If you don't sit by somebody, I'll put you there. I'll give you a group if you don't find your own. All right, that's all I got for you for the video for today.